Okay, so here I've got a 10 kilogram bar, horizontal, springs unstretched, at rest. I want to find the stiffness so that when it gets down to 45 degrees, it comes to rest. Okay, so all I've got here is a spring, gravity, conservation of energy. So KE1 plus PE1 equals KE2 plus PE2. Now, a lot of these things are going to equal 0. It starts at rest. KE1 goes to 0. It ends at rest. KE2 equals 0. So at this point, I know it's unstretched initially, so why don't we just call that our datum, right? So we'll call this our datum. So PE1 is 0. So all I've got is PE2. Okay? So 0 equals PE2. So now let's draw what's going on here. So got this guy, 45 degrees. That is the new length of the spring. The length of this side is 1.5. The length of the other side is 3. Right? So essentially I need to find the length of the spring. Well, first of all, let's do the gravity, right? This guy is dropped down below, right? The center of gravity has fallen below the datum, so it's going to be negative, and it's going to be negative 0.75 times the sine of 45. That is the distance that it's fallen down times the weight, which is going to be 10 times 9.8. Right? So that's the gravitational potential. It's fallen below, that's why it's negative. Okay. Now if I just find the length of that side, I should be good to go. I'm going to use the law of cosines. Right? So if I call this L, L is going to be equal to 1.5 squared plus 3 squared minus 2 times 1.5 times 3 times the cosine of that angle of 45. Okay, and from that, this then becomes 2.21. The stretch in the spring then is 2.21 minus its unstretched length, which we know is 1.5, which gives me 0.71 as the stretch in the spring. So the potential of the spring is always positive, so it's going to be plus 1/2 k times s squared, which is 0.71 squared. Now, of course, k is what I'm looking for. Everything equals 0, right? Or PE2 equals 0, so I just solve this equation for k, and I find that k equals 206 newtons per meter.